Good afternoon, students. Today I am going to discuss triple five timer and its application. Last class we have seen that how triple five timer was the triple five timer, its operation and working, how it is built in triple five. Similarly, from that I have to move the triple five timer in its application. Different types of application like monostable, different types of application like different types of triple five timer like monostable, astable, and bistable. Using triple five, we are using Schmidt trigger, and one of the most application that is called as a monostable multivibrator using triple five timer application that is called as a frequency divider. Similarly, this is the overview of. In this presentation, we are going to discuss this topic: introduction of triple five timer, different application of triple five pin configuration, pin detail, internal architecture detail of triple five timer, types of triple five timer circuits, operation of triple five timer, then graphical representation, and mathematical calculation, and practical circuit. Similarly, introduction to the triple five timer. The triple five timer is a is one of the most popular and versatile in IC ever produced. It was introduced by Hans or Kamenzind in 1970, brought out to make in 1971 by Signetics, later acquired by Philips. It is 30 years old and is still being used. It is a combination of digital and analog circuit. From that, it has been claimed that the triple five gets its name from the three 5K circuit, 5K resistor using in typically early implementation. Typically, it has 8 pin, but it has various version. Ultra low power version of the triple five are also available. It is known as time machine as it perform a wide variety of timing tasks. Variant ICs available including the 556 that is called as a 14 pin dip IC, and 558 is called as a 16 pin dip IC. Similarly, the triple five have four significantly modified. So application for the triple five include bounce free switch and cascade timer, like you have to see in the three cascade, two cascade in UG level classes. So similarly, this is an important application of monostable that is called as a frequency divider, then VCO, then pulse generator and LED flasher, then linear ramp generator, then pulse width modulator, pulse position modulator, then frequency divider. Similarly, this is another one. This is a missing pulse detector, metronome, bicycle light, sweeping frequency siren, voltage inverter, voltage doubler, running and rotating light generator, infrared remote control, frequency to voltage converter, power alarm, and dark detector. This is a simple diagram of pin configuration of triple five. You have to see in the previous classes. I have to discuss in the last video, lecturer one, that is called as a triple five timer, how it should be a generator. The pin number one is called as the ground, the pin two is a trigger, pin two is a output, pin four is a reset. So pin 5 is a control voltage pin, pin 6 is a threshold, pin 7 is a discharge, and 8 is a plus VCC. Similarly, these are the detail of the pin. So you have to see in the video. Similarly, this is the inside triple five timer IC. These are the inside the triple five IC. This is the RS flip flop. RS flip flop. The Q is the output. The pin number 3. The Q4 is belonging to transistor at the uh, drain source level. At the drain and gate should be connected to resistor. Similarly, the S flip flop is connected to non-inverting amplifier. Then R flip flop is connected to the inverting amplifier. This two comparator begins the difference between R1 and R2. It should be calculated from the reset and discharge pin. From that, we will move to the internal circuit. The voltage divider blue, the blue is called as a voltage divider. This is blue shows the three equal resistor that is called as a 5K. This is the R1, R2, R3. This is a three equal resistor. It belongs to 5K. It divides the input voltage VCC into three equal parts. The two comparator rates, that this is the two comparator rates, are op amps that compares the voltage at their input and saturated depending upon which is greater. The threshold comparator. pin number upwards saturates when the voltage at the threshold pin number 6 is greater than 2 by 3 VCC. Pin number 6 is 2 by 3 VCC. The comparator should be a high. The trigger comparator low, saturated when the output voltage at the trigger pin is pin number 2. This is a 1 by 3 VCC. This area is 1 by 3 VCC. This area is 2 by 3 VCC. This is the upper comparator. This is a lower comparator. So similarly, the flip-flop green, the green, the green shows the flip-flop RS flip-flop is bistable device. It generates two values, a high value equal to VCC, the low value equal to 0 volt. That is called as a ground. When the threshold comparator saturates, the flip-flop is reset and it outputs a low signal at pin number 3. When the trigger comparator saturates, the flip-flop is set and its output signal is high at pin number 3. The transistor purple, the transistor, this is a transistor, is called in the color giving the purple. The transistor is being used as a switch. It connect to pin number 7, discharge to ground when it is closed. When Q is low, Q bar is high. This closes the transistor switch and attach pin number 7 to ground. When Q is high, the Q bar is low. This open the switch and the pin number 7 is no longer grounded. This is the types of triple five timer circuit. There are three types of triple five timer circuit: monostable, astable, and bistable. We will see in the next classes. So see, this is a monostable multivibrator circuit, the pin configuration of the circuit in which the one pulse is the connected, one pulse each time the switch is connected to the monostable multivibrator. Similarly, the control pin should be connected to the one variable capacitor, and the pin number should be grounded. The trigger pulse should be empty. Before that, we are going to this area. She shows the pin number 2. It shows a square wave generator. From that, we will see the charging and discharging capacitor later in the next slide. So similarly, this is a monostable multivibrator. These are the block diagram. How the block diagram should be changed? Like that, we have to told that the trigger pin number 2 shows the input wave, input square wave, that is 0 to 1 by 3 VCC, 1 by 3 VCC, 2 by 3 VCC. Like that, we are going like that going on. Then we will see the plus VCC. From that, discharge, threshold, and control voltage across 2 by 3 VCC will be developed from the spike type. So output should be a reverse form of the triggering pulse. So these are the block diagram should be used in the monostable multivibrator. Similarly, in the diagram you can see that we have connected the resistor RA and I connected the resistor RA. This is the RA between the supply voltage and the threshold voltage. Also the threshold and pin number is shorted. So similarly, pin number 2 and 6, from that we have to shorted the pin number 7 and pin number 6. From that, pin number 5 is empty. The capacitor, the capacitance C is connected between threshold and the ground. The function of this capacitor is to suppress noise and deliver energy during the transistor time of the output. Between control voltage and ground pin, a capacitor of the capacitance 0.01 microfarad is connected. 0.01, this is the area, that is 0.01 is connected. So operation, we know that if we leave the capacitor alone, then the capacitor will discharge gradually. So initial, we can consider the voltage of the capacitor as 0 voltage. Now start the sequence of capacitor. We apply a negative triggering pulse, negative triggering voltage shown in red color in the left side. Shown in red color is the red side. This is the input area. So we have shown in the red color in left side. When the trigger voltage goes below 1 by 3 VCC, 1 by 3 VCC voltage level, at the time in the lower comparator, positive pin voltage become less than negative pin voltage. So similarly, has positive pin in fixed with the 1 by 3 VCC in triple five resistor network, and the negative is connected with the trigger voltage, so the output of the comparator CL become high. Now you can see the output of the comparator is connected to the S terminal of the SR flip-flop. So we know that if we give S is equal to 1, R equal to 0, in SR flip-flop, the output becomes Q is equal to 1 and Q bar equal to 0, which starts the output signal, start the output signal portion shown in the red. It becomes high as shown in the output output graph at the right side of the picture. This is the output graph of the right side of the picture. It should be a change from the charging and discharging capacitor from 1 by 3 VCC to 2 by 3 VCC. So at the same time, the capacitor starts to become charged through the resistor RA from VCC and continues up to voltage level 2 by 3 VCC. Suppose the capacitor takes time to reach the voltage level 2 by 3 VCC, so the output remains high during the time period T shown in yellow. Shown in yellow. I have to see this. This is the time period when the capacitor is charged, it gradually increases like a 2 by 3 VCC. Suddenly it will gradually down to zero. So this is the meaning. We have to changes in the colorful diagram, that is called as red, yellow, and similarly red and yellow. So yellow at the output, and during this period any trigger voltage applied in the trigger pin will have no effect on the output. Now the capacitor reaches to voltage level 2 by 3 VCC and exit the voltage at the time. In the comparator, the positive pin voltage become less than negative voltage level, as positive pin is connected with capacitor and negative pin is fixed with 2 by 3 VCC voltage level in the 555 resistor network. Here you can see that the R pin in RS flip-flop is connected with the output of the comparator, so the input of the RS flip-flop is 0, S is equal to 0, R is equal to 1, and the output Q is equal to 0 and Q bar equal to 1. This is the logic of RS flip-flop. As shown in figure, Q is connected with the output of the output, so the output becomes low, shown in green color in output graph. Again, we started the Q bar is connected with the gate of the discharge BJT, whose collector is connected with the capacitor and the emitter grounded, so that the gate voltage is high. Then the gate opens and the capacitor discharge through the capacitor and becomes zero voltage, low voltage. It was initially shown in the capacitor characteristic graph. Now the whole circuit is in the stage as it was initially. Now if we give another trigger pulse at the trigger pin, then the whole sequence start again. By this way, the 555 timer work has monostable multivibrator in which we get a regulated time output pulse for each trigger voltage. This is the graphical representation how the trigger at pin number 2 should be started. It started at 0 to 5 at 5 voltage. So similarly it will gradually decrease and gradually increase. So at the particular level it reaches the maximum position. Then similarly it repeat the cycle. So it repeat the cycle, the further trigger pulse ignore the during the time period. So similarly at pin number 3 the output should be a changes from the pin number 2 to pin number 3. The trigger makes output high. This is the time period T. From that we have to calculate the one duty cycle, then the another duty cycle. From that capacitor is charged. Capacitor charging that starts charging, then it should be a gradually decrease and gradually discharge from the uh, 0 voltage to 2 by 3 VCC. So this is the graphical representation of the monostable multivibrator. Similarly, in which the mathematical calculation for equation was charging the capacitor equal to E1 minus whole power minus T by Ra into C. Here E is a charging capacitor, E is the power supply, then small e it shows the base of natural logarithm. Now the voltage across the external capacitor changes exponentially from 0 to 2 by 3 VCC is given by Vc is equal to VCC 1 power minus e by 2 r by c. This is at t, the time t equal to capital T, then Vc is equal to 2 by 3 VCC. It should calculate the total T equal to 1 minus 1.1 Ra into C. Therefore, when the output is high, the time interval becomes T high is equal to T. So this is from that I have to stop the monostable multivibrator, its operation and its working, and mathematical term and graphical representation. Hope you have to understood. From that we can move to the another application, another practical circuit. Some of the frequently used practical circuit are linear ramp generator, missing pulse generator, Number three is a pulse width modulator. Number four is a frequency divider. Number five is a 10 minutes timer. So from that first practical circuit is a missing pulse detector. You know already missing pulse detector. This transistor can be replaced with ECG or NTC 1.159. This is a pulse detector we are using in the daily routine. Daily routine that is called as a ECG. This is just a basic model but works experiment with the values of resistor and capacitor. This is a good example would be a crashed aircraft locator beacon used in radio control. If there is no signal, it says it is a missing pulse and sound buzzer. This is a basic missing pulse modulator. Similarly to the resistor, one of the resistor that is IC resistor 3960 3906, this will be connected from the input is the output shows the diode. From that value should be a same as a monostable multivibrator. So from that another application that is called the pulse width modulator. Pulse width modulator produce a PWM signal. This is a communication signal, a pulse with a constant frequently but with the duty cycle varying according to the modulating signal. Here is a schematic diagram of the pulse width modulator circuit using 555 timer IC has an active component. This pulse width modulator circuit needs external pulse train input to trigger the 555 monostable circuit. This trigger input should be square wave signal with a fixed frequency. The output of this pulse width modulator circuit will have the same frequency with the trigger input but with its pulse width proportional to the modulating input signal at pin number 5. This is the block diagram of the pulse width modulator. How the graphical changes from top traces, there is a modulation 1 division, the bottom is a 2 volt division. This is a changes from this is a similar to this pulse width modulation, similar to 555 timer circuit. So if, this is a 10-minute timer. It can be used in the timeout radio position. Radio. This is a communication signal. You should in the green area. Let to light fed up. This is a simple cycle of the 10-minute timer you are using in the daily rotational. But in which the main point is we have to see in the at the this is a potentiometer. This is a 500K potentiometer we are using at the 330 volts of the ID 330 resistant component we are using from the diodes. This is a diode. The signal should be a 2M2. So from that, I have to stop the 555 timer and its application like monostable. So in future we are seeing the more stable Schmidt trigger like frequency divider. Hope you have to understood the small lecturer of small topic. I have I have to conclude the. If you any doubt, you can ask in the comment section. Thank you.